Hi everyone, this is Sayed Ali Mirhidari from University of Trento. I'm going to present our paper titled Cache and Confuse Web Cache Deception in the Wild. Basically, web caches has become an essential component of the internet infrastructure with lots of use cases such as reducing bandwidth. Web servers use cache control headers to define a policy to communicate with web caches. For instance, cache control no store header indicate that the response should not be stored in cache server. Even though web caches must respect this header, they offer configuration options for their user to override, ignore header instruction. Simple caching rules are based on URL structure such as path, file name, and extension. Traditionally, URLs reference with resources by directly mapping them to web server's file system structure. Example.com/file/index.php correspond to the same files/index.php at the web server document root directory. But also, web server introduced URL rewriting mechanism abstraction way to implement advanced application routing structures. In a RESTful URL, clean URL, example.com/index.php/v1 is clearly means example.com/files/index.php p1 equal to v1. Browser proxies and other man-in-the-middle HTTP components are not aware of this layer of abstraction between the resource file system path and its URL. They process the URL in an unexpected manner, also known as path confusion. In other words, web server parse, process, and interpret URL in a way that are not clearly reflect in the externally visible of the URL. Omar Gil used the same idea and introduced a web cache deception attack in 2017. Web cache deception in these pictures actually has 3 steps. In step 1, the attacker tricks the victim into visiting a URL that requests account.php/nonexistent.jpg. At the first glance, this appears to referencing an image file, but in fact does not point to a valid resource on the server. In step 2, the request reaches the web server and is processed. The server, in this example, applies the rewrite role to discard the non-existent part of the requested URL. As a result, the server sends back a successful response 200 OK, but actually include content of account.php in the body, which contains private detail of the victim's account. Unaware of the URL mapping that happened at the server, the web server stores the response as a static image. Finally, in step 3, the attacker visits the same URL, which results in a cache hit and grant him unauthorized access to the victim's cache account information. There are a couple of questions beside the web cache deception. In this research, our goal is to cover them. For example, what is the prevalence of web cache deception vulnerabilities on popular and high traffic domain? To answer this question, we present our measurement methodology for a large-scale analysis in 3 stages: measurement setup, attack surface detection, and web cache deception detection. In measurement setup, we selected our target among Alexa top 5K and extract related subdomain to increase site coverage. We also create 2 sets of accounts, attackers and victims on them. In this step, we also populate victims' account with predefined unique markers that can later be searched for successful web cache deception attack detection. In attack surface detection, we ran a recursive crawler on each domain in the seed pool to select and filter candidate pages. And finally, in the final step, we craft an attack URL that references a non-existent, such as random value.css, to each URL from the victim account. Visit same page also from attackers, authenticate attackers or unauthenticate attacker, and compare responses to detect web cache deception. Interestingly, from the 295 sites comprising the collected data set, the crawler identifies 6 sites to contain web cache deceptions for about 17,000 vulnerable pages that we were successfully exploiting. We observed that the distribution of vulnerable sites we observed that the distribution of vulnerable sites is roughly proportional to the number of sites crawled. We also investigated actually on vulnerable responses, and we noticed that 16 vulnerable sites, about 17,000 vulnerable pages leaked PII, including name, username, email address, and phone number. And also, interestingly, we detected 6 vulnerable sites in about 130 pages, leaked CSRF token that we were able at the times to bypass the secure implementation of CSRF protection. And at the end, we noticed that 6 vulnerable sites leaked also session identifier or user-specified ABI token, which the attacker can utilize web cache deception attacks to do the session hijacking. Also, our results show that web cache deception can fully exploit with unauthenticated attackers. This implies that web cache deception as a class of vulnerability tends not to require an attacker to authenticate to a vulnerable site in order to exploit those vulnerabilities. Also, we studied the path confusion techniques, and basically web cache technologies may be configured to make their caching decision based on complex rule. Based on this fact, we hypothesize that exploring variation on the path confusion techniques may increase the likelihood of triggering caching rules and a valid web server response, and make it possible even to exploit additional web cache deception vulnerability on sites that are not impacted by the original proposed attack. To test our hypothesis, we perform a second round of measurement and apply the new path confusion techniques B, C, D, and E. The path parameter is the traditional way proposed in 2019, but we added all of these techniques to our crawler and ran a new experiment. Interestingly, results confirm our hypothesis that launching web cache deception attack with variation of path confusion increased possibility of successful exploitation significantly, and we found 43,000 vulnerable pages among 25 sites. Some variation of path confusion elicit more 200 successful response of the server, increasing the likelihood that the web server return more sensitive information. And also, we observed that each path confusion variation was able to attack a set of unique pages that were not vulnerable to other technique. And finally, we studied some side channels beside the web cache deception. For example, in order to answer this question that attacker location is important in web cache deception or not, we selected 19 vulnerable sites and run the experiment in this case that attacker now located in Trento, Italy, and victims is in the Boston, United States, and we noticed that only 6 out of 19 were vulnerable, which means that attackers' location is pretty important in web cache deception exploitation. Caching exploration also, it seems attackers in web cache deception have a limited window of opportunity to launch a successful web cache deceptions, mostly because web caches typically store objects for a short amount of time. And at the end, we tested the basic content delivery solution offered by major vendor to extract the default configuration and study the presence of the web cache deception in default configuration. We noticed that many major CDN vendors do not make RFC compliant caching decision. It means, or at least they give a capability and functionality to the user to override the caching control. And at the end, I want to conclude this presentation that configuring web caches currently is not a trivial task. Caching and CDNs are not intended to be plug-and-play solution. Cache roles based on file extension are prone to security problems. As web cache deception impacts almost all web cache technologies, there is widespread lack of user awareness, and there exists no technology to reliably determine if any part of system is vulnerable. We believe web cache deception is generally a system safety problem. In an environment with web cache deception vulnerability, there are no isolated faulty component. That is, web server, load balancer, proxies, and caches all individually perform the functionality they are designed for. Then security researchers should adopt a security analysis to examine not only individual system component, but also their interactions. And at the end, variation of path confusion techniques introduced in this paper make it possible to exploit sites that are otherwise not impacted by original attack. Thank you, and I would be happy to answer your question.